How close are we to interstellar travel? Right now, we're stuck on Earth. We breathe its air, drink its water, and live under the protection of its atmosphere. But what if something catastrophic happens? Could we just leave, pack our bags, and head off to another planet, another star system, another home? Before we even think about traveling to other stars, we have to know one thing. Where would we go? Because if you don't know where you're going, well, you're not going anywhere. So is there another planet like Earth out there? Thanks to decades of research, astronomers have now identified thousands of exoplanets, worlds orbiting stars outside our solar system. Among them, one stands out, Kepler 452b. Discovered by NASA's Kepler Space Telescope, Kepler 452b orbits a star remarkably similar to our Sun. Even better, it's located within its star's habitable zone, that sweet spot where temperatures could allow for liquid water. Water, of course, is essential for life as we know it. Kepler 452b is about 60% larger than Earth, making it a super-Earth. We don't yet know its exact mass or whether it's rocky or gaseous. But if it is a rocky planet, and if it has an atmosphere, and if it has water, then it might, just might, be a place we could one day call home. But there's a catch. Kepler 452b is 400 light-years away. That's 13 to 30 trillion kilometers. To put it mildly, it's very far. Even other nearby stars like Alpha Centauri, our closest stellar neighbor, are still over 4 light-years away. That's about 40 trillion kilometers. So the big question is, could we actually get there? Let's start with what we've already done. In 1977, NASA launched 2 space probes, Voyager 1 and Voyager 2. Their mission? Explore the outer planets of our solar system, and then keep going. Voyager 1 is now the farthest human-made object from Earth. In 2013, it officially entered interstellar space, meaning it passed beyond the influence of our Sun. It took 36 years to get there, but let's say Voyager 1 were headed toward Alpha Centauri, which it isn't. At its current speed of 62,000 km, it would take over 70,000 years to get there. And if it were heading toward Kepler 452b, we'd be talking millions of years. So clearly, our current technology isn't going to cut it. Let's look at what we do have. Chemical propulsion, the kind we use in rockets today, is powerful, but horribly inefficient. Most of a rocket's mass is just fuel. And even at maximum speed, a space shuttle would take over 165,000 years to reach Alpha Centauri. Ion propulsion, used in missions like the ESA's Smart 1, is much more efficient. It can run on just a few dozen kilograms of xenon gas. But it's slow, maxing out at around 56,000 km. Then there's gravity assist, using the gravity of planets to slingshot spacecraft and gain speed. Voyager 1 used this method with Jupiter and Saturn to reach its current velocity. The current record holder, Helios 2, reached a speed of 240,000 km using the Sun's gravity. Still, at that speed, Alpha Centauri would be a 19,000-year journey away. So, is there anything faster? Yes, sort of. Some of the most intriguing ideas are still in development, or exist only in theory. Take the EM drive, or electromagnetic propulsion. A controversial concept, it supposedly uses microwaves to create thrust without propellant. If it worked as hoped, it could reach Pluto in less than 18 months. And Alpha Centauri in 13,000 years. Still not fast enough. Then there's nuclear electric propulsion. It's more realistic, but would still take over 1,000 years to reach Alpha Centauri. Other concepts, warp drives, fusion rockets, antimatter engines, even wormholes, are purely theoretical right now. They exist only in math and science fiction, but one idea has gained real traction. In 2016, a group of scientists and visionaries launched Breakthrough Starshot. Backed by names like Stephen Hawking, Mark Zuckerberg, and billionaire Yuri Milner, the project aims to reach Alpha Centauri in just 20 years. How? By shrinking the spacecraft down to the size of a microchip, mounting it on an ultra-thin light sail, and blasting it with high-powered lasers from Earth, accelerating it to 20% the speed of light. That's 60,000 kilometers per second. No people would ride on this chip-sized craft, of course, but it could carry sensors and cameras, enough to study a nearby star system and beam the data back. It's still a massive engineering challenge, but it's the closest we've come to true interstellar travel. If you're enjoying this journey through the future of space exploration, make sure to like this video and subscribe for more deep dives into science, space, and the mysteries of the universe. Your support helps this channel reach more curious minds like yours. So where does that leave us? Right now, interstellar travel for humans is still out of reach. Even the fastest spacecraft we've ever built would take thousands, if not millions, of years to reach another star. We don't have warp drives. We can't bend space-time. We're stuck for now, but that doesn't mean we'll always be. Breakthrough Starshot shows that with enough imagination and enough investment, we might send probes to the stars within our lifetime. And who knows what future generations might invent. After all, just 100 years ago, the idea of landing on the moon seemed like science fiction. Now we have robots on Mars and telescopes looking deep into other galaxies. The human drive to explore, to go further, to learn more, to find out what's out there, isn't going away. It's what brought us out of caves, across oceans, and onto the moon. Maybe one day it will take us to another star. Thanks for watching. If you enjoyed this video, don't forget to subscribe and explore the rest of the channel. New videos every week about science, technology, and the universe around us. See you next time.